Good evening, everyone. Today's session is on registers that are in computers, right? So, we will be going through the basic concepts of computer architecture, how the registers are basically storing the results, how we perform the different operations on the numbers, and that is used and stored in registers that are in memory. So, let us begin with the session. First of all, this is the architecture. We have a bus that connects everything: input output devices, CPU, and RAM. Right? So, in this bus, like you can see on my screen, the first that is connected to CPU, which is the central processing unit of computer, and then this bus is connecting all the other hardwares too. Right? Let us show you what are the others hardware. So these are the other hardwares which are basically this bus is connecting. So how we connect, like we have keyboard, we have mouse, we have display board, we have monitor or display, we have CD-ROM or pen drives or hard disk. So they all are connected. How they are connected to each other? Through a bus. So bus is the main, you may say, a connecting device which connect different hardware input output devices. And the main thing is which we have, which is doing everything, which is processing, which is performing everything, that is central processing unit, the brain of the computer. Now let us start with to understand what is a bus. It is a simplified way for many devices to communicate with each other, to connect with each other. It's like a basically it's look like a highway for information, right? Actually, more like a basket that they all share. Yes. So they all are connected to each other and they all share that particular basket that is known as bus. So bus is the most important part in any network or for connection of different devices, for connection of various hardware or input and output devices, right? So let us understand from the diagram also. You have a bus and that connects the different input and output devices, your CPU, your keyboard, your monitor, right? Suppose CPU needs to check to see if the user typed anything. Now we are performing any function, we are giving input to the computer. Now what is the first step? CPU needs to check to see if the user typed anything. How it is going to check? From the keyboard. Keyboard did the user typing anything, right? And CPU puts keyboard did the user type anything represented in some way on the bus. So it's the brain of the computer which basically checks out everything. And from where we are getting the input? From various input devices that we have done. We have already discussed the input and output devices in the previous sessions. So we have understood, like, there is one bus which is connecting all the hardware or the input and output devices, and the brain of the computer now it is deciding whether any input is given by the user or not. Now how the user is going to give the input? Using input devices. What is the input devices that is mentioned on my screen? That is keyboard. So we need to use keyboard. The CPU is going to check out whether the user has typed anything or not with the help of keyboard. Now keyboard, basically what do you mean by like state, right? Each device except CPU. Why CPU? CPU is the brain of the computer, is a state machine that constantly checks to see what is on the bus, right? So CPU is the thing which is going to check everything, right? Keyboard did the user type anything? right? So you may notice from this particular slice, every device has its own motive, has its own aim. Keyboard is going to check out whether any input is coming from the user or not. Display is going to check out whether anything should be printed on the screen or not, should be displayed on the screen or not. CPU, obviously, it is the brain of computer, connecting all the hardware devices, and the bus itself, which is basically the main thing, which is a connection that is given to different devices. Keyboard notices that its name is on the bus, right, and reads information. Other devices ignore the info because the keyboard notices that its name is on the bus. So keyboard basically uses an input device, so it knows this thing, how to have the input. Other devices ignore because their role is different, not taking the input. Keyboard then writes CPU, yes, user typed A to the bus. Right, now keyboard, when it receives any input from the user, now it is going to react. Now it sends the message to the brain, that is CPU. Like it is same as our body. If I put hot cup of tea on my hand, that particular neurons get activated and sends the message to the user, and remaining neurons will not get activated. This is same as with computer also. So when we receive any input, it should be checked with the input device itself, right? And then that input device is going to send the message to the brain of the computer. So that is, who is the brain of the computer? Which device is the brain of computer? That is central processing unit, right? So this is how basically we connect different hardware devices with a bus. At some point, CPU reads the bus and gets the keyboard's response. CPU, yes, user typed a A. Now CPU responds, right? CPU basically reads the data and gets the keyboard response. Because I told you, I have taken one example. If I put a hot cup of tea on my hand, that particular neurons only get activated and sends the message to the brain. So everything is, then brain decides, like it's a hot or whatever the message is conveyed to the brain. Now brain decides everything. Whereas where the cup of tea is not placed, obviously that neurons are not get activated. So other devices are not influenced by this input. The device which is taking the input is only get influenced by that particular input, right? Let's see. This is the computer architecture. We know that the brain of the computer is central processing unit. The other input and output devices are keyboard, display, or you may say it as a monitor, RAM, random access memory, hard disk for storing some data, right? Then CD-ROM, read-only memory. So in later lectures also I am going to tell you about the different architecture of, like I am going to show you a board where different how these wiring, how this is a bus, or how other devices are connected to each other. Like in when we are doing any kind of programming in you may say um, breadboard is used, which is basically connecting the different wires with different ports. Here also we have that. So here we have the concept of bus itself, which is basically connecting the different hardwares, right? Now inside the CPU is the brain of the computer. I told you number of times which is the brain of the computer, that is the CPU is the brain of the computer. It is the part that actually execute the instructions. So all the instructions that are given to the computer are done by CPU, are sent by CPU. Look, let's take an example. Now whenever we have anything to start, temporary memories, like what does it do and what computer do? Let us start with that. Computer loads the data from RAM to registers. So computer basically what is the role of that? To load the data from main memory, or you may say RAM, to registers. Now basically the operations that are performed on data that are performed in registers, and always it stores the result from the register also, right? And it stores the result from the registers, and then when it gets the result it stores back to the RAM itself. So suppose we are talking about registers, memory registers, it may have register 0, 1, 2 and 3. So starting with the example, read value of A from memory, read value of B from memory, add the values of A and B and put the result in the memory variable, that is C. The reads are done to registers. So what is the role of these registers? Basically for performing any operations, right? And then we are getting the result and then putting that result in the main memory itself. So we are taking the inputs from the main memory, and then after processing in the register we are putting those results into the memory itself. The reads are done to registers, the addition is done to registers, and the result is written to memory from a register. So this is the important point that we have. What is that important point? Computer that loads the data from RAM to registers. So why we are loading into registers? To perform the operations on these registers. Basically these registers are helping to perform any operation on 2 variables or 3 variables, and then when we get the register, when we get the result, we are going to load that result from these registers to random access memory, that is RAM. So this is how it works, right? Let us move to the next point. Arithmetic logic unit for doing basic arithmetic and logic operations on values stored in the registers. So whenever we talk about CPU has three main components. What are those? Arithmetical logical unit, control unit and memory unit. So the first unit that takes place, basically it performs the operations on values and stored in the register and store it in the registers, right? So we have memory registers, we have the first unit, that is ALU, arithmetic and logical unit. The second unit we have is control unit, and the third unit we have is memory unit. Now once we have these registers, there is an instruction register which is basically holding the location of current instruction. It holds the current instruction to be loaded into the memory, right? Instruction pointer. Instruction pointer to hold the address of the current instruction. The first what is the first instruction? First of all, to hold the current instruction to be executed, right? Second, make a address of that current instruction, right? To hold the address of the current instruction. The instruction register basically holds the instruction, the current instruction to be executed, whereas when we have instruction pointer, it holds the address of the current instruction in RAM, right? Then we have, I told you, the second very important part, that is control unit or state machine. What does it do? It all comes down to the control unit, which is just a state machine. How does it work? Let us see. Control unit state machine has very simple structure. What is that? They have some cycle procedure. and those cycle procedure have some instructions. First is fetch command. Ask the RAM for the instruction whose address is stored in IP instruction pointer. Whose register, whose instruction is in IP. What is IP? Instruction pointer, right? So fetch instruction, what it is going to do is it asks the RAM for the instruction whose address is stored in the IP. Execute cycle, there are only a small number of possible instructions which are going to be executed, depending on which it is do what is necessary to execute it, right? And repeat the task, that is add 1 to the address stored in the instruction pointer and go back to the step 1. So basically it works like this. This is a control unit. It's a state machine. You fetch some instructions, you may have some load part, you may have some add operation, you may have some subtract, you may be basically doing some operations on that. You may have some go to statements, you want to store some data in the memory, so it could be anything, right? And there are a number of things which can be done. There are a number of operations basically which can be done on data, right? And how it is going to be done on data? With the help of this thing, right? Fetch instruction. Let us move to next. Yeah, so after this we have studied execution part, that is execute, right? Now execute is going to whatever we have fetched, right? The next step is to execute them. Then once we have executed, all the instructions have done their work. First addition, load, it is not in a sequence, it is like whatever instructions is coming, they are performing like that only. So they fetch the instruction, they basically satisfy the operation, whatever the operation is going to do. Like if it is going to add, then add. If it is only going to load the instructions in the memory, it is going to load the instructions into the memory. It is executing those points only, right? And then after that, once we have executed all the statements, again we have to repeat the steps. Add 1 to instruction pointer to repeat these steps. This is basically how it works. Yes, so now once we have added 1 to instruction pointer, this pointer is going to, again the same steps are repeated. Again it has went to fetch instruction. Now fetch has different operations. You may have go to, you may have store, you may have load, you may have add, you may have any operation that is needs to be performed. Then execute those statements, execute those operations, and after that execution of these, we need to increase the instruction pointer, which is what is the role of instruction pointer? The role of instruction pointer is to have the address of the current instruction, basically the next instruction to be executed. So IP stores basically that the next instruction, the address of the next instruction to be executed. So now from this session, what we have learned, in today's session we have learned about how different devices, how different hardwares are connected to each other, like CPU, your input devices as well as your output devices. After that, once we have understood this, what is a bus? Bus is a connective device which connect all the hardwares and all the input devices with each other, right? And then we have understood that CPU. What is a CPU? CPU has 3 main units. What are those? Control unit, arithmetic and logical unit, which uses registers, then control unit, then under control unit we have perform, execute, basically fetch, execute and repeat those steps. Then inside the computer, we have already discussed the computer. The CPU is the brain of the computer, right? Then after this is the very important thing. You should know why the data is coming from here and going from there, right? So you should know whenever a computer loads the instructions, loads the data from RAM to registers, then we can perform operations on these registers. So there could be accumulator register, there could be many registers which can be used for performing these tasks, right? And after having the result, it stores the result from registers. रजिस्टर ने तो अपना काम कर दिया, they have completed their job. Like if there are addition of two numbers, so the operations that are performed on two variables are done in the registers. Now we have that particular result, the register is holding that result. Now we need to do is we need to transfer the result from these register to the RAM, right? And then we have understood what is ALU. I told you arithmetic logical unit are basically used for, this unit is used for performing the arithmetic operations on values stored in the registers, right? So suppose I want to add, I want to load, I want to do any operation, and or not any operation, I can do it. I can perform it on the values and store it in the registers. The most important, there are two terms what we have come across, that is instruction register, which is holding the current instruction. Now the instruction pointer, what do you mean by pointer? Pointer is holding some address, so it is holding the address of next instruction to be executed, or you may say the instruction of the address of the current instruction in RAM. Then control unit, control state machine, which has its own working. So control unit is very simple machine, simple state machine, which has performed the various functions like fetching the data or loading the data or adding the data, or you may have, if I have generated if any interrupt occurs, then also it is done by this only, that is control unit, right? You may have fetch, then after fetching the instructions, after fetching the data and performing the different operation, we may have different instructions. On different instructions we may have to execute them. Now the next step is to execute them, right? So basically what we have learned from this particular part, like instruction pointer is the main pointer, that is any control unit that is used by the control unit, because if we does not increment that, so how we are completing, how we are basically freeing the space of registers? How registers are only meant for only single purpose? No, they are meant for performing number of tasks. So if we are not deleting the result from the registers, and it would be having the same result and again it is going to print that. So the output will be incorrect. How to remove this problem, how to come out this problem? We need to add 1 to the instruction pointer, right? So that we can move to the next instruction. If we are not using the instruction pointer or instruction register, this cycle would remain incomplete. It is of no value then. Why? Because again and again only one statement will be executed. We are not moving to the next instruction. The registers will be holding the same value, right? So it's very important to increment, to add 1 to the instruction pointer, which is holding the address of next instruction, right? So I hope these concepts are very much clear. In the coming session I would be giving you introduction to different packages, right? And what are those packages? The packages on like MS Word. I will be showing some hands-on experience on MS Office, and mainly we will be discussing on Word files, how to make tables, how to insert, how to make paper, exam paper in a Word file. So there are what are the different tabs in Word file, or then in later series we will be having hands-on on Excel sheet, and then we have hands-on on PowerPoint too. So you should know each and every office tool that is used in our daily life, because everyone is using this nowadays. Everyone should be tech savvy, computer savvy. Why? Because everything is to be done on computer itself, right? So in this case, in the next session I will be taking the topics, that is how to have tables, how to have labels, how to have colors, different font colors, different font styles, changing the size of a font, then thesaurus, how to check the spellings, how to check the grammatical mistakes, that we will be seeing in the packages of computer applications itself. Right? The most widely used packages are Word, PowerPoint, and Excel spreadsheets. Nowadays, we are using Google Apps also. Like we may be using this Google Docs, Google Sheets, or Google Forms, right? So they are also very easy to use, and at the same time, two-person, three-person can access that file at the same time, right? Like if I'm using Word document, so it is a static document, and I'm going to use that document. If anyone who wants to add something, I need to mail that document to the next person. So it is not an online tool, right? So for Google Apps, it is the main advantage why we use that Google Apps. Why? Because number of people can add their content and can work in the same document at the same time. Like I am adding something, someone else is also adding. So it can be possible by only Google Apps, right? Mostly widely used apps are Google Apps. That's why we call them like they are very helpful, and also they are very helpful, like for generating reports, for making attendance sheets, for making exam forms. You have Google Forms, you have even MS Teams forms also, right? So we will be in the coming series, we will be learning more about how to use Word files, what are the different tabs that are present in the ribbon bar, what are the different icons, the number of shortcuts that we have, because everyone does not know the shortcuts. So by using the tabs, we can have different shortcuts also. Control X, Control V, Control Y, Control Z. So there are number of shortcuts also that we will be covering in the later series. Right? I hope you like this session, and uh, we will be meeting soon to have other lecture series also. Thank you.